Well, hello. I hope I'm live and you can see me here. This is Nono, and this is my new live streaming setup. So today I wanted to record a few tutorials, and I'm gonna try to do it live. Let's see how it goes. I'm just gonna show you what I'm intending to show right now. So I just posted a link on Twitter, so that's one way that people can get the feed. And also, if you follow on YouTube or if you subscribe to my channel, you will get notifications when I go live, right? So let's get started. Let me see. I have a few things here. Okay, so I'm here. Today, as I said, as the title of the live stream says, we're gonna learn how to visualize convolutions with TensorFlow. I'm on the process, as somebody trained as an architect, but having spent, I don't know, maybe more than 10 years doing software development and 3 years now doing it as a full-time job. I am in the midst of learning or becoming better at machine learning. As a designer, as an artist, as an architect, I have been tinkering with TensorFlow lately. I'm tinkering a lot with Python, trying TensorFlow JS as well, trying models that are out there that are available for anyone to use, and trying to customize my own models, and also using things like Google Cloud Platform or AWS SageMaker or other platforms to learn how to deploy models into the cloud. If you've seen some of my talks, you might have seen that I've also used Runway, which is an awesome tool. I would definitely recommend you to go and look at it if you don't know what it is. And I'll be doing tutorials also on Runway, how to use Runway, how to do machine learning with Runway, how to use the models that are out there, and also how to wrap your own models. So this means learning how to create your own models or get a model that is out there and wrap it as a Runway model, be able to expose it for yourself to use it there as maybe HTTP server or a WebSocket server, but also as a way to make it public, to offer your model for other people, other creators to use it, right? So what we're gonna see today is visualize convolution with TensorFlow. So we're gonna create a simple TensorFlow convolutional model in Google Colab. So I'm gonna show you what Google Colab is in case you don't know. It's just, it's a really amazing tool. It's free. It's wrapped, I think, around Jupyter Lab, not the normal Jupyter Notebook, but the more advanced Jupyter Lab version. What you can see there is just me trying to pass my profile picture through one convolutional layer with 64 filters and a kernel size of 3 pixels. So 3 by 3 matrix is the different kernels that modify that image. And so we will try to just create that TensorFlow convolutional model. We're gonna see how to export the model, visualize it with Netron. So Netron is just an Electron tool that allows you to drag and drop models. In this case, it's going to be a Keras H5 file. And when I say export the model, it's actually more in more TensorFlow opinionated ways. It means saving the model, right? So you have a model that you build on the session, and then you want to save it so you can reuse it later in other environments or in the same, maybe even to deploy it as a cloud service or in a local application, right? What you can see there here on the bottom is that the model is going to be super simple. It's just going to be an input that we're going to define by being an image of 128 by 128 by 3 channels. Those are the RGB channels, and then just pass the image through a 2D convolutional network layer to get the result that we saw before, right? Then we're gonna, as I said, convert the model or save it and convert it to TensorFlow JS format. That's we're gonna use the Python tool TensorFlow JS Converter. We're also gonna see how to do that in Python code. Hopefully we get time. And we're gonna feed the model. This is probably the most interesting part. Feed the model with the live webcam feed of my machine or your machine in TensorFlow JS. And what we're gonna do there is that we're gonna build a really simple web app, just an index.html file. We're going to use the latest, so AES 2015 spec of JavaScript that we're going to compile with Laravel Mix. That is a wrapper of Webpack. And we're going to serve the site with HTTP server just to run it on Google Chrome on our browser. This is the outcome that I got when I tried things like this. So just this is a sped up, I don't know if by 10 times or by double time or something, but this video shows that I'm feeding an image from the webcam, and then with TensorFlow.js and visualizes some of those layers and the filters of on the convolutional layer. So yeah, let's get started. I am happy that you joined, that you're watching, and now we're just gonna get hands-on with coding. All right, so the first thing I'm gonna do, as I mentioned before, I'm going to close all this stuff. Let's see if we have something more open. I'm gonna leave that here. So I'm gonna go to colab.research.google.com. You can see that's the URL where you can access Google Colab, what I mentioned before. And when you get to here, right now for me, I have a bunch of notebooks that are with the extension MB, right? Like the Python notebook format. And so actually, let me get back 1 second. I'm gonna just record the cover in case that I do a tutorial with this. So I'm just gonna get back and record that. Hi, it's Nono, and this is gonna be, we're just gonna build a simple TensorFlow model, so the simplest model that I can come up with, that is gonna take an input image, so some JPEG that you have on your machine or somewhere that you feed it from, and pass that image inside of a model by a 2D convolutional network, right? So we're gonna do that in Google Colab, and hopefully that way you get more familiar with what the concept of TensorFlow model is, building it and passing an input through it. Okay, that's done. So let's go to new notebook. And as I mentioned before, Google Colab is free. You get TPU and TPU for free. That you have to go here on the run type and select GPU type. That's what we're going to use today. By default, you can see you get I think Python 3.6.9 if they haven't updated it to 3.6.10. And if we, while this is loading, you know, we have just been allocated a runtime there. Yeah, 3.6.9, and TensorFlow, we can import it, and if we print the version of TensorFlow we have, I think we're gonna get 2.2.0. So that's the latest stable build of TensorFlow. If we click here on this folder, we see there's some sample data that we have here, but for now we're gonna ignore it. I'm gonna make this a bit bigger so you can see better. And you know, the first step we need to do, just make sure that TensorFlow is working, right? So we could define a tensor by doing tf convert to tensor and just put here an array of numbers, and then let's print that tensor. And you know, that should output a TensorFlow tensor. That's simple. That's just to verify, you know, everything's working. We get it. We ask for the tensor shape is going to be 3, it's just 3, and that's it, right? So you can see if we do, for instance, this. This is like a 2x3 matrix, right? So when we run that, we get here is like 3x2 matrix actually, and then we get that the tensor shape is 3x2. So let's get started. So let's get this code out from here. We can delete cells here, right? So in case, you know, let me just explain something in case that you're not familiar with Python notebooks. So if I want to, you know, what a Python notebook is, every one of these code blocks, right, or cells that they call it in Jupyter, in the Jupyter world, is a cell that's going to execute Python code. So if I do, for instance, a equals 1 plus 2, right, the variable a is allocated to 1 plus 2, which is 3, right? If I do this, right, if I just put a variable at the end, it's going to output the value of that variable. That is the same as if I were to do that. So print a, and we're just printing that variable, right? So a common way that I often use, many people use, is that you just do some operation, and then whatever value you want to see at the end, you just put it at the end. You don't need to put print. It's pretty convenient. But you know, you can do even functions, so def sum, and then you can say here a and b, and then we can say return a plus b, and we define the function. We gotta run it, so it gets defined on the environment, and then we can do result equals sum 10 and 20, right? And we put here result, and we're gonna get that value, right? So that, you know, just a simple overview of what Jupyter is. There's a lot more. The other thing I would do is, like, if you put the bound here, right, exclamation mark, we as you can see, I did here, this is a bash terminal command. So I could do, for instance, ls, right, to list the current directory, and as you can see here, I have sample data. That's what it is. I could create a file, and then if we do the ls again, you can see that that file gets created here, and if you list, it's there. So you could also do remove that file, right? So those are, I mean, some of the core concepts that I have, at least I know from Jupyter. And now we're gonna get started with what we said we will do. So we're gonna do, let me see. So the first thing that we want to do is we imported TensorFlow, but the first thing we're gonna do is that we're gonna build a model, and later we need to import an image, whatever image we want, and pass it through the model. So feed the model with an input that is an image, a raster image, and see or visualize what the output of that is. So the first thing, you know, you just say my model is whatever. So we can build a sequential Keras model. So Keras is a higher level API around that is integrated inside of TensorFlow, and you can use these API not only in TensorFlow but in other libraries. I think PyTorch doesn't support it, but I think Theano and I don't know if Café, but other libraries also support it. So if we do this and we do model.summary, what we're doing is building a model, and you can see that we cannot call the summary because it hasn't yet been built. We need to call the build fit command before we can run that command, right? As we said before, right, I showed you this slide before where we wanted to build a model that would get an input of 128 by 128 pixels with 3 channels RGB, and then pass it through a convolutional network layer to the 64 filters, which is actually generating 64 convolutions, right? So what we do first, we first do this, we just add the input layer. So you can see as I'm typing here, well, it doesn't work perfectly, but as I'm typing I get some auto completion. Sometimes it gets frozen there. So we just do this, and what we need to do here, you can see we need to specify, we're getting the autocomplete there. So we get asked to at least put the shape of the image, and if we want a name, and then there are other parameters that we can put there. So the first thing we're gonna do, as we said, we're gonna put the shape here and then the name. So the name is just gonna be image, and the input is gonna be 100 by 28, 128 and 3 pixels, so 3 channels. And then we're gonna add, as we said before, convolutional layer. Again, we get asked filters at kernel size, and then other optional arguments. So filters, we're gonna say 64, and kernel size, we're gonna do 3. This, you know, the kernels. So let's see, convolution kernels pixels. So let's see if we can find a diagram, quick diagram of what the kernels look like. Yeah, so these would be the sample kernels, right? So these are 3x3 matrices that mean operations that get applied over and over and over for an image, and when you apply that, basically you activate or deactivate different pixels on the throughout the image, and this is, I think for me, it's a bit hard to explain, but as you can see, this green map here is like if we were like moving that kernel, right, the same kernel over the whole image by rows, and that is going to generate some sort of filter or output image for each of those kernels, right? So we will have here 64 kernels of 3 by 3, so that's like 3 rows by 3 columns. So we can visualize the output later. So the next thing we will do here is called model build, and you know, if we do that, nothing happens. But if we call here model summary, beware that, you know, this is fairly small code, but if I rerun the entire cell and don't put the model summary in a separate cell, so if I do this, it's going to run the entire code. So it's going to run these statements plus this one. But if you don't want to do that, because we're defining here the model variable, we can run this here. So no model summary is logged in there. And then we do the model summary here. And this only runs the model summary, so it doesn't run the other part of the code. Okay, so we have our model here. So we have, it's a sequential model. We have just one layer that is going to return 64 maps of 126 by 126. The fact that from 128 we went to 126 is because the nature of the kernel operation, we're actually getting some inset that we lose the pixels on the corners of the image by doing that, right? Another thing that we can do is we can visualize the model. This is similar to the diagram that I had before. So Keras has these utilities to plot models, and we just have to pass the model through. So we pass the model, and then we generate this. So we have the input layer that we call the image, and then the convolutional 2D network layer that we will pass the image through. You can see here we named this image, this layer image, and that's why it shows like that. We didn't name this one, right? I would adventure myself that we can name this. So custom font the name. Let's see if that actually works. And yeah, you see, so we could name each of the layers in case we want to reference them later, because we can. There are ways that later we can reference certain layers to get their outputs or their activations or things like that. So what we said we had to do, right? We said before that we were going to export the model and visualize it with Netron. So this is our model. So we build the model, and if we wanted to save it, the easiest way you can do is like you can just save it, and TensorFlow is intelligent enough to do this. So if we save to model.h5, it's going to save it on Keras format. And there are other ways that you could save. Let's try, if you say we save it just to model. If you use Keras, blah, blah, blah. Let's see. You see, so this actually is telling us some information there. The model that we just saved, I save it to model, and it's actually saving on PB file, so PB format, right? That's a different format that can be loaded in the same way, so with the same API, but it's a folder that has the PB file and then some variables that include the data of the model. But for now, we're gonna stick with the H5 file. So let's go and download that model file. So we can get that here. Gonna put that over on my desktop, and I'm gonna go and open the Netron app. So the Netron app, as I mentioned before, is an Electron application. So this is an app that the simplest its core function is to let you open a model and visualize it, right? So I can drag and drop. This gets loaded, and as I mentioned before, we just get this sort of diagram here that I can zoom in or I can click on. So if I click on, you can see that the API we used was Keras 2.3.0 for TensorFlow. The runtime was TensorFlow. The input name was, name input, that decided to put. It was image. I don't know what that's not showing there, but the output has the name that we wrote for it, right? So it doesn't show up here, it shows up here. The convolutional layer, we get some more information here, and yeah, that's it. We can see that the kernel size is 3 by 3, the filters are 64, and some other information. So we visualized the network with Netron, and now what we said we have to do is load an image. So we're just gonna get a random image from the web. So let's just get I don't know, maybe a kiwi bird. This is the real reason why people from New Zealand are called kiwis and not because of the kiwi fruit. I think I don't really know if this is called kiwi because that is the shape, same shape of the kiwi, or if the fruit, well, this is interesting image, or if it's the other way around. Okay, so I'm just gonna use this one. Iconic New Zealand, iconic kiwi bird. Oh, it's a WebP. I just actually would like to get a JPEG to avoid file format issues. All right, we got an image there, so I'm gonna drag and drop here the kiwi.jpg image, and fair enough, Google Scholar is reminding us that any uploaded files that we put there on the bucket or on the folder of the Colab notebook, it's gonna get deleted, or when the runtime is recycled, as they call it, so you disconnect from it, or you close and then come back after half an hour or maybe a few days, the files are not going to be there. Your notebook code will be there, but not the images or the models you save or the data you've used. And as you can see, this notebook, the notebook file, it doesn't really show up here. Usually in Jupyter you would have that file, so untitled 4 show up here. So let's actually just name this. Visualizing convolutions with TensorFlow. All right, so we refresh here. We have kiwi.jpg there, and TensorFlow gives us an API to define, so to load image data as a tensor, right? So we will do here TensorFlow IO read file, and we just say kiwi.jpg. Again, we can debug that that's working, and we have already a tensor, but it's just, I think it's just binary information, so it's not actual numbers. That's what we want. We want the actual numbers, a matrix representing the colors, the RGB channel. So what we need to do for that is with the IO, so decode JPEG, and we need to pass the contents and the channels. If we don't pass the channels, I think you see it says it here actually. We use the number of channels in the JPEG encoded image, but we want to make sure that we have a 3-channel image, that we don't have an RGB or we don't have a RGBA image or something, even though this is a JPEG. So we convert the image D type, so we're gonna get this image and we're gonna say TensorFlow float 32. And I think, so what this does, let's actually try to understand what we're doing as we're doing it. So if we put this here, we get the tensor, right? And yeah, what the D type means as a float format is that we get an image tensor that where values range from 0 to 1, right? It gets mapped, maybe the image was in the space from 0 to 255. And what this command did is, and they were probably, let's actually not just make up stuff, so let's just try to see it. So I think it was integers, yeah, from 0 to 255, that's what like the JPEG format is. So what we do here is map the range from 0 to 255 to 0 to 1, and then make those floats. Otherwise we'll just get zeros and 1, right? The image would be not really detailed, we'll lose information. We can actually try that here. yeah, well, I don't know what this is doing, but just mapping to huge integers. All right, so we were here, so we're getting our image tensor, and then the last thing, if we do here image shape, we're gonna get the resolution of the image. So 681 by 1024. That's actually height and width, so they're flipped because of the nature of the matrix. If we do this, so, and this is something that usually you can get confused, because when you do your resize and you get the image to 128 by 128, for instance, when you do image.shape, you might think that this here is the height, so the width, and then this is the height. Usually the convention for images is width per height, or like width, height, and channels. But in this case, due to the nature of the matrix, this is height and width, right? But if the image is square, we don't really care that much. Let's actually try to visualize that. So we got the image here. Let's say we just verify that we got that shape right. And what I'm gonna do now is I'm gonna import matplotlib pyplot. We get, it's really nice in Colab. We get helpers, so if you don't remember things, they might try to help you out. And you know, after we import this, what we're gonna do is a plt image show img, and then plt show, and hopefully we'll just visualize that kiwi fruit. So kiwi bird here, right? We can do, I think, axis off to not get those axes. Okay, we get a nice plain image, and you know, I'm just gonna clean this up a bit. We're just gonna put that with our dependencies. So load dependency libraries. Just put this here. Okay, we can. Yep, we visualize that here, we save the model, we load the image. Okay, what I wanted to do before, you know, just to visualize that thing of the sizing, let's just do this here. So now we have, you see, it's height and width. So width is 256 and then height is 128. So because our model needs 128 as an input, we're gonna go back to that square image. All right, so now we have the interesting moment. So we have tensor image, that is img, and we have a TensorFlow model, that is model, right? I'm here. So this is exciting. I mean, we can now format that image in a way that the image tensor can be passed through the model, and then we'll get the convolutions performed in that image. All right, so let's see. The model needs an image, and this is gonna fail, but we're just gonna try to predict, right? So we try to predict with the model. Oops. So it's telling us that let's hide this here, that the input 0 layer sequential 5 is incompatible with the layer. So we expect a dimension 4 and we get the end dimension as 3, right? Full shape received 32, 128, 3. Well, I don't really know why it says it's 32 when we have 128 here. Yeah, but I knew that this was gonna happen, right? So the model actually takes an input formatted like this. So well, this is a convention in TensorFlow. So non means that you can put any number you want. Non 128, 128, and 3. So this is the end dimension is 4. So we have 4 components on this vector, and the first one is going to be the batch number. So this is going to represent whether we have 1 image, 2 images, 3, 4, 5. In this case, we're just going to have 1. And then this is going to be our first image. So component 1 is going to be an image of 128 by 128 with 3 color channels that are RGB, right? So let's just say here. So batch, size, height, width, and then RGB, right? Well, let's say channels. That's fine. All right, so let's see if this works. Yes. So what do we do for that, right? Let's leave that there. And what we're gonna do is that we're gonna call our image input, and our input right now has shape 128, 128, 3. What can we do? So the operation we can do is we can do TensorFlow expand dimensions of image on the axis 0. Let's see what happens with that. Yeah, so now we have an image that is of, well, a tensor that is a batch 1. So we have one image of that size. So this should be an input that the model can take in. So we just do model predict. So we're gonna, right now we do model predict, expect not to get any errors. So that's at least the first thing that we can do. Yeah, so we actually get an output, and this is, it's an array, it's a tensor with a shape, hopefully, of, the 64 filters. So we could call this prediction or filters, but let's just do prediction for a more generic term. And as you can see, we have a batch of 1, and we have 126 by 126 filters. We have 64 of those filters. So this is, this was a bit hard at first to understand for me. So what you need to do to visualize that is just go over each of those filters and render them as an image. So let's try to do that. So the size that we have, so imagine we have a matrix that has 64 filters, so that's 8 by 8. And we can say the square number there is 8. So we do an 8 by 8, that's 64 filters. And we're gonna have our index start at number 1 because we wanna go from 1 to 64, right? And what we're gonna do first is we're gonna do 2 ranges, columns and rows, or rows and columns actually, and we'll just go getting that the information of each of these subplots. And I'll explain what we're doing here. So we just get this done there, blah, blah, blah. Show, and here's the important part, right? So we got the prediction there, and what we need to do is from that prediction, right? Let's actually, let me actually go back for a second. So if we have that prediction, right, what do we need to do to get just one image, right? Let's see. So when we have, we want to go, yeah. So we have this that is a batch. So before we had the opposite problem. So we had a batch of, so we just have one image, but to pass it through the model, so we had an image that looked like this in shape. And to pass it through the model, we needed to make it like this. Expand the dimensions, right? Like this one, right? So once we have that image, what do we do to go back to the original image, right? So right now we have a shape 1 with height with channels, and we want to go back to something like this, or actually something like this, because we just want to get one filter at a time. So what we do for that, let's see, we do prediction 0.shape, right? So we got, it's like if you had an image with 64 channels, that's actually what we have, and each of those channels is a convolutional filter of those that I showed at the beginning, that you can see here, for instance, right? So you can see each of these is one of those filters. This is an 8 by 8 matrix. And how do we now visualize that, right? So we have that our output, we can say, is that prediction, now we got this. So how do we now go through each of those images and visualize them? The easiest way is that you could say output and get everything, so like the 126 values from the image data, but just let's get the first channel, and then we get something that is 126 by 126. That arguably is a black and white image, right? We just have like values in each of those in each of those pixels, right? So it's values from -1 to 1, and this is actually an image. So this is a filter. So let's do. So this is our filter 1 is this one, or filter 0, however you want to call it, but 1 out of 64. And we can also use Matplotlib to visualize that. Yes, so that's the first filter. You can see that it's green and blue. That's the color map that Matplotlib is using. So we use Inferno, for instance. We get that. So it's like a heat map. And if we put gray, we'll just get a grayscale image. Right? There's a bunch of them. We can see more later. There's a bunch of names. You can try. If you put something that doesn't exist, you'll get an error. Yeah, we'll not spend time on that right now. So let me just put that to gray. Okay, so we got the image there, and you know, now it's pretty simple. So if we 0, we get the first image. We just need to go iterating from 0 to 64, getting those values. What I was doing here is just try to build the matrix, so we visualize all of those images in one Matplotlib plot. So we can, you know, the thing we need to create here that I didn't do is that we need to create a figure that we're gonna specify the size. This is just to specify how big we want the image to be. So now we can say, okay, we're gonna output that image, but instead of saying 0, we're gonna do ix -1, and again we're gonna use the gray color map. All right, and now we just need to increase that number and execute. Oh, okay, yeah. So let's just try to do that. Oh, again. Ha! Nice. Okay, it worked. So, you know, we've got pretty far already. So we are already visualizing those 64 convolutional filters that we're passing through the image. As you can see, you know, to learn a bit of what this is doing, let's actually get another image as an input, because this, you know, that's an image that you can understand, but let's just look at something that is a bit more representative of what we want. Let's just say maybe this is a JPEG. You know, you can also decode PNG or other image data, but I'm just trying to go with JPEG for now, right? So here, all right. So I'm just gonna do a quick conversion there. So we got this image here. Let me just do a bit of cleanup here. Well, we have important files for now. We're gonna be the model and this JPEG. All right. Cool. So we said we were going to get this image so we can show a bit of what's going on behind the scenes. So everything we need to do is just change the keyword for AG. One thing you can do here is run all. So you rerun all the cells on the notebook. So this will recreate the model, save it. It will fail because something's failing there. AG JPEG not existing. All right. Once again, run all. All right, so we got this image here, and the only reason why I wanted to add another image that is different is because this is the power of filters. Neural networks learn features from images that you can see here, and the things that you're learning here from the image is just trying to calculate the edges in some way, right? It's applying different filters. You can see here the contrast with the background with the foreground, and applying different filters that in some way are adding depth, are adding emphasizing the borders, the edges, and other information, right? So that helps a neural network after doing many layers. Right now we just have one. It learns about patterns. It adjusts the weights of a deep neural network according to many of the operations here. In the case of convolutional neural networks that try to do image classification to detect objects, and that the most famous case there, or the most used data set, you can see here, right? The TensorFlow model image is convolutional. That's something that is included with TensorFlow by default, because it's one of the sample networks that are usually used, right? Here you see some of the things that get used are convolution, the padding, the kernel. There are multiple layers. There's also max pooling that does some other operation to those filters that we're visualizing, and of course there are many other layers, right? But what we're seeing right now is just the convolution, what they mean, what they are, what those filters are, and this is the visualization. All right, cool. So we got so far so good to through some of these points. So we have created the model, we've exported the model, visualizing Neutron, we've converted the model. We haven't converted the model, but we've visualized those convolutional layers inside of Google Colab. And now we're going to convert the model to TensorFlow JS and try to then feed the model into a live webcam feed and build a simple web app with that. All right, let's get going. So we have the model here, and as I said, you need to convert that model to be able to be used in TensorFlow JS. Cool thing is, we could create another notebook from scratch and load the model. So just with this line, so I have this model here, I could send this to anyone, and let me see. Well, I'm not gonna do that right now, but just with this line of code, just with let me just show another notebook that I have here. All right. I just realized the music was running on the background for the whole time. That's something I knew will happen, but whatever. I didn't intend that to be like that all the time. All right, so we're gonna close Neutron. I was talking that we can visualize the convolutions, and we can reuse this H5 model in a different inside of a different notebook without having the definition of the model. So here, for instance, we're loading that H5 file and we're visualizing the layers. Here you can see that this is another network that I tried, but let's actually get this one over here, because that way, once we load that, the only difference we'll see is that we have a custom name here. That is the name that we added to the network, to the layer of the convolutions. All right, so the model is loaded, so we can now load these two and load the model and see the summary. So the only thing that should change is this name here. Yep, so we get the custom name. So this is actually loading the model, so we can load the same image here. Once that's loaded, we can read the file, resize it, and do the same thing that we did before. Right, so this is visualizing with the Inferno color map, but as you can see, the same thing. This one, for instance, edge detection, emboss, they're doing different filters, different operations that will get used by the neural network to understand it. All right, so how to convert to TensorFlow JS, right? So let's actually go back. Hey, Ashkan, how's it going? Nice to see you here. All right, so can you hear me well? I think there is a bit of delay with the audio, so just wanted to check in. All right. So, so far we've gone through creating the simplest convolutional model that I could think of on TensorFlow and Google Colab, and we've built the model. We've imported an image as a JPEG, decoded that as an image tensor in TensorFlow, and we were visualizing the convolutions. So you've seen the 64 filters that this convolutional layer was generating, right? That neural networks generate a lot of those, but we usually don't see them. And what we want to do now is that now we exported that model to a model H5. We want this format that you can see here. We want the model.json and the shard of binary data that will allow us to load those that model inside of a Google Chrome tab with TensorFlow JS. All right, so let's move a bit faster. So with this in mind, right, you can see there is a tool called TensorFlow IDs Converter that if I click here, I don't really have, right? You're gonna see this here, right? But if I go to Bash, I already have an Anaconda environment that does have that tool installed. This is a tool that you would installed with pip installed TensorFlow JS Converter, I think, or TensorFlow JS. So install it. Let me see. I added a link here so we can refer to that. now. So yeah, so this is the command that I ran, so I can run again, but I already have it. So pip install TensorFlow JS, right? Yeah, so this is a command that you would have to run if you don't have that. For me, it's just telling me I have it installed already. And the simplest command that we can run is what we're gonna do right now. So I'm gonna go to my desktop. So you can see here, I can see the model H5 file, and I'm going to run this command here. So TensorFlow JS Converter, the input format we're using is keras. We're gonna say my model H5, and the output is gonna be, let me actually make sure I create a folder. So we're gonna make a folder called model TensorFlow.js. Model TensorFlow.js. Boom. Right, so this is gonna do its magic. So it's gonna do the conversion, and now that it's done, I can go to my desktop. I can open the folder, and then we have those, right? You can see if we inspect with Visual Studio Code, we inspect this folder, what we can see is a binary folder that is contain, well, a binary file that is this shard that cannot be displayed, but we have the model.json file. So if we format this document, this is really interesting because we're converting that model, and in some way I think that's what the Netron is doing. So we can see here the same information that Netron was reading. So we see the layer of the convolutional layer, and we see the size. So the input size is whatever batch, 128 by 3, and the shape of the filter is like a 3 by 3 matrix, 64 filters, and this is the name of the output, the weights that will be trainable. And as you can see, image, there's no trace of the input image name, which we could see before in the summary, but it's not visible here. So yeah, I mean, I would guess that's just how it works. We're just gonna leave this as it was. So we've exported our model to TensorFlow.js, and now what I want to do, I'm gonna actually do this really quickly. So I'm gonna do it live. So let's just create a new repo on GitHub. We're just gonna call this TensorFlow.js Convolutions live public. So visualize 2D convolutional layers with TensorFlow. Right. We're just gonna build a bit of a node project, and I'm doing this open source as right now live, so you can access that right here. And I'm just gonna clone that to my desktop. All right, so with code dot, I open this folder in Visual Studio Code. That's my editor of choice. I hope yours as well. I know a lot of people still use Sublime or I even forgot the name of GitHub's text editor, code editor. All right, so what I'm gonna do, I'm just gonna move these. I'm just gonna create here. How can I say, like a public folder that we're gonna serve with HTTP server, and I'm gonna go now again into here. So in this public folder, I'm gonna do npm init, so just to start an npm repo project here. And the first thing we're gonna do npm install TensorFlow tfjs, and I'm also gonna install Laravel Mix. That's so Laravel Mix is a wrapper around Webpack that, you know, they say serves the 80% of the case, and with really simple code such as this one, you can bundle up an application. You don't even need to configure Babel or any other tools. There's also even plugins for TypeScript, which I really like. But today we're just gonna work on JavaScript. So I'm gonna create an index.js file, and you know, the first thing you would do is like import everything as TF from TensorFlow TF.js. And if we were to run this, so we, you know, you see that doesn't really work. So what we need to do is that we actually need to use, let me put here Laravel Mix. We need to transpile the JavaScript to a JavaScript that can run on Node and on the browser. So let's see, okay. Okay, so, you know, Laravel Mix is going to allow us to compile this to be run on the browser, right? So we could do, for instance, this just to verify that TensorFlow is running, and you know, for Laravel Mix to work, we just need to add a few commands. I'm gonna copy that over. That's something, you know, I just usually just copy that over because they're a bit of verbose commands that we don't really need to go through right now. But they basically just run the command to compile the application or watch for changes, and that will be there on the open source repo. So I'm just adding here a bunch of commands, right? So right. So things that we haven't installed. So I haven't installed Riffraff or Babel, which I should. That's just to be able to run the JavaScript file that is written in ES 2015 specification. And then for the development, just to build with Webpack with Laravel Mix, we have these commands here that are gonna let us compile our index.js for the web, right? So while this is going, I'm gonna have to install as well Rimraff, Babel, I think. Let me see actually what dependencies are installed here. Yep, so the Babel CLI, Babel preset, ES 2015, and we already have Laravel Mix. A note here, I put these for making sure that that's only installed for dev. Okay, Laravel Mix is installed, so we're gonna install these ones as well. And now we should have everything. The other two dependencies that I'm actually gonna install as well are TensorFlow JS data and TensorFlow JS node, right? So I think with this we have enough. I haven't really explained what we're gonna use each of these for, but I will in a second as we go. So as you saw before, if I run node index.js, we're getting this error. But if I do npm start now, that actually should work. Oh, cannot use import statement. All right, yeah. So for Babel to use the okay, let's just look it up here. So this is just to show, I just want to show that we can run this directly from the index.js file. Yeah, I think this is it. Let's just try once again. Yeah, okay, so we're running this with Babel, so this works, and this wouldn't work if we don't have Babel, because this is written using new JavaScript syntax that is not supported everywhere yet, but that works, right? I'm gonna remove that for now, because we're gonna use Laravel mix, so that's gonna be webpack mix.js, and here what we need to do is to require Laravel mix and just call mix JavaScript from index.js to public index.js, and we're just gonna try with npm run dev. Npm run dev. Right, so as I said before, this is similar, and this is gonna have to install some other dependencies that Laravel Mix installs on the first run. But I've added this command here. So the dev command calls npm run development, and then development uses a cross env as a development build to use webpack and the config that we've created to build our assets, right? What will you get with this? We'll get an index.js file here in the public folder that we'll be able to use from our website. All right, so this is now building. All right, so we got that index.js. This has a lot of code here that is just to make it cross-compatible. So this bundles up the TensorFlow.js dependency and the code that we added. So let's see. Oh, this is pretty big. Yeah, I don't really know where our code is, but you know, we can do this npm run watch, and that is going to be looking at our index.js file for any time there are changes, it will rebuild. So let's say we do here Nono is live, right? So now this thing, well, this takes a bit, I think, but yeah, now this is watching the files, and it's going to be rebuilding every time we modify something on the code, and we'll wait for that. All right, so that compiled, so Nono is live, and that should be in some way, because that's a hard-coded string. So Nono is research, right? That's there. And if I now, I don't know, if we just put that there, that should change in our build, right? So automatically gets built every time, and we can now use that from our website. So we're gonna make an index.html as a recap. We have a folder here that has this directory. The distribution file is just the distribution file the distribution folder is the folder that contains what Babel is built, and you know, it has the public file and the index and all that stuff. We're not going to care about that right now. We're building our public folder manually. So an index JS an index.js that is being built by Laravel Mix and the model that we exported with TensorFlow JS Converter. So what do we do now, right? We have an index file here that is empty and that we're going to write some code for right now. So we'll just make just gonna make this by hand. Yep, and here body. This works. All right, so we can open this. So I can go to a terminal and they open index.html. Oh, it doesn't exist. So open public index.html. Right, this opens here, but it's not actually serving, so we cannot reference things on the public directory. So what we're gonna do is say PHP server, and we're gonna serve the public folder and open that. So right now, you know, this is loading. This is an HTTP server that we have. HTTP server, in case you don't know about it, you can install it on your machine globally if you do this. It's a node package. How useful. And you know, I can go here and maybe just make here a folder, my website for instance, go to the desktop, web, and say HTTP server dot, so that means the current directory, and then open, and then I serve this as a static website, right? And you know, if I do this and make an index file for here, this is my website and here's an image, and then we can do right. So we just save that, and now that's my index file. And you know, you can do anything you'll do in a static website. So serve files and create HTML pages. I use that for serving this here. As you can see, we go to the Google Chrome's console. There is nothing really happening there, and that's because we haven't loaded our script file. So I'm gonna do this. So script, the source is gonna be so index.js, and we're gonna defer it. So this is so we put this script on the header, so on the head of our website, but so it loads after the body, right? So we can actually you see, this is the model. This is we've printed TensorFlow, the TensorFlow JS library, and then Nono is here. That's a bit heavy. We're just gonna remove that from there, and actually just remove that here. So this is gonna be index.js loaded, and so now we have that here. So we have the, let me just make this font bigger, just put the info here. So the we're now getting that rebuilt every time. We're gonna just put this here, and if I were just for to show you, so if I were to add some JavaScript here, even though this index file is above in the head, I've put this deferred thing. So now hello world runs when you're loading the body, and then index.js, so this file gets loaded when the document has loaded. So it makes sure that we're gonna reference elements on the canvas, on the HTML5 canvas, that we can that they're available when the index.js gets loaded. All right, so first thing that we're gonna do in here is add a webcam. Hi Chandra, how's it going? So we're gonna just add an HTML. Where is that HTML? let me see. Okay, yeah, so the first thing we're going to do is to add a video item, so a video element that lets us load the webcam feed, and because we're going to use the webcam feed image to pass it through the model that we've trained, or well, that we've created. We haven't really trained anything. Right, as you can see here, so you can see better, I'm just gonna do this. This is, I kind of got this practice when I was learning React, so this is sort of the idiomatic React way to put HTML attributes. All right, so we have that, and we're gonna add some other things programmatically afterwards. So let's see if we get, right, we don't get anything yet because we haven't added anything to actually activate the webcam on this page. So right now what we need to do is load the model. So load the image from the webcam, load the model, and perform an inference, so predict with that model. All right. So the first thing, as we said, we're gonna create. We're gonna get the image from the webcam, and we're gonna get the model loaded, right? And here, because we're using the transpiling, we can use asynchronous functions as well that are gonna be handy for loading the model and getting images from the webcam. So we get the image. So we just say webcam capture, right? And let me see. So when we do, this is something we haven't really defined the webcam item. So the first thing we're gonna do, we're just gonna make an initialization function, and we first want to try and get the webcam to see if it's available for us. The TFD is the TensorFlow data API that I haven't loaded yet, but I will in a second. And we're just gonna get the webcam HTML5 element that I loaded before. Right, so this is gonna give us an error. You can see here. But I'm just gonna load import everything as TFD from TensorFlow TF.js data, right? Hopefully that builds now. Oh, error. Okay, so blah blah blah. What's going on here? Say sync function init refactor, remove this statement. All right, there's a build. Yeah, okay. So that's building, and now, if we get, let's see if we reload the website, we're not even calling this function. So let's just call the function to init the site. And okay, I'm here. Well, look at that. That's my that's my green screen. So which you cannot see on my on my other cam, but this is where I'm actually at. And you can, we can load the model, so we need a function to load the model as well, that we're gonna do right now. So we loaded the webcam, so we're not gonna have a function to load the model. That's gonna be, we have the variable here, so we just need to say our model is gonna be a weight tf load layer layers model. And now this comes handy, right? Because if you go here, you can see that because I'm serving this folder that has the model.json, we just need to load this URL, and the model will know how to get the shards file, so the binary file from there. And now we can even print a model summary, right? So now this is an asynchronous function, so we're not really calling it anywhere, but we're gonna call it on the initialization function. So we're gonna try and say load model. All right. Three warnings. All right. Yeah, so you can see this is nice. So we can get here the information about the model that we're loading. So let's just put here the information so we don't get we get everything there. All right, so you can see we're getting the custom conv 2D name layer that we saw before, and we have the same parameters and we have the same shape of that. So we need to pass the same size of image as an input. So we've loaded the model, but we still don't have a way to pass the image of that webcam into the network, right? So let's see how we can do that. So get the image. So we need to see what we need to do now. All right, so we need a function to get the image from the webcam that I was trying to write here before. So let's just put it here, and our image is gonna be a capture from the webcam that we've got started here. And now we need to process the image to be, so we can pass it to the webcam, right? To the model, right? So we do this here. We're just gonna have a function there that's gonna be called after we load the model. So get image, and it's gonna log whatever image we've loaded. Right, so it's a tensor 128 by 128 by 3, and that, the size here is defined because the webcam, actually I made it on the HTML file, I made it be 128, and because the image that you're getting from the webcam feed is actually an RGB image, so with 3 channels. So that's handy because we don't really have to do anything there, but we do need to process the vector, so the tensor, right? And for that we're just gonna do processed image, and we're gonna run this function here. So we're gonna expand the dimensions of the image. That's something that we did before in Colab. We're gonna convert it to floats so we don't lose precision, and we're gonna divide it to 255 to map it from 0 to 1. And I think that's it. That's all we need. And then now we're going to dispose the captured image that we got from the webcam, because we have the tensor here, and we're going to return it on this method. So now this method actually is returning the image. We can call it from anywhere we want. So we just now need a predict method. So some method that we can call to predict the filter, so pass the image through the network and get the convolution filters, and then find a way to visualize that on HTML on the website. So again, we're gonna make another function. It's called predict, and the first thing we do is capture current webcam's frame. So we just get that as get image, right? So that's what we just coded, and now we predict. So we have the model, so our prediction is going to be the model.predict with the image. And if we log the prediction's shape, we can log here prediction.shape. Right, let's see if that builds. Right. Okay, so we're not calling predict from anywhere, right? So the first thing we're going to do here is that we're going to call predict. Right, I closed everything. Right, so let me just open that again. Okay. Right, so we call predict in there, and now we need to restart the npm run watch command. Let's see if that actually worked. All right, and also I killed the http serve command. Server public open. All right, we're back on track. Right, so this is still building, so we haven't really built the thing. All right, I'll be back in a second. Right, so far we've we've built TensorFlow JS and loaded the model, so we saw the summary, and we're seeing that that's working. And right now we're calling predict here, and we should be getting a prediction, but I'm not sure. Let me just reload, refresh in. Cannot read property predict of undefined. Okay, so we're loading the model there, but I did something wrong here. So, not really. Load model, okay, maybe await, and then await predict. So so yeah, I think probably the error is that we were calling asynchronous methods and the model wasn't getting loaded. Yeah, okay. Prediction shape test, that's good. So you just make sure, if you're creating asynchronous functions, to add the await call here when you call the function if you don't want it to run asynchronously. So this will wait, so wait for this, and wait for this, and then synchronously run all of those calls. The good thing here, we're getting the filters, so the input image from the webcam is actually passing through the network and or model and giving us those 64 filters. So now we just need to visualize those, right? To visualize those, again, the same thing that we did before on Colab. So we need to add 64 images, so 8 by 8, to visualize those filters. On the initialization code, I'm gonna add here another function that's gonna be not asynchronous actually. Create canvases, and what we're gonna do is that we're going to say we have 8, so that's like 8 by 8, 64. And the same thing that we did before. So we let the index be 0, or actually, yeah, be 0, and we do a loop. So for let I 0 e smaller than square e plus plus. We're gonna put this to be 2 first, but we'll change it later. So j equals 0, j smaller than that, j plus plus, and then we're gonna make a canvas element. So that's we just create the element canvas, and we do append it to the body. So we append it as a child on the body. So that will just append right now 2 by 2, so 4. If we put 8, will be 64 canvases. So we want to make sure that the width is 126 to hold the image that we're going to get from the filter. The height is also that, and to reference that, we're going to say that the canvas ID is going to be output and the index number, and then we just need to do index plus plus or index plus 1, whatever you feel more comfortable with. After each row, I'm gonna append a jump, so a line jump or line break. We're just gonna do that. But we do need to create an element, so document create element vr. All right, so these should create the canvases. So let's see, before we do anything, we can create the canvases. How do we inspect this? We just need to look at the HTML trees, because, right, error, model failed. Right, where are you failing? 34, 34 here, right. Build successful. All right, so now that's working. If we go to elements and we go to a body, we see that, you know, we have 2 rows with output canvases that are here but are empty. So we can see we highlight there canvas 1, so 0, 1, 2, and 3, right? And those, you know, for those, we just create them, they're empty. And now we're gonna visualize our each of the filters from an image that we've got from the network as images. So we're just gonna get the information there. One thing that I didn't do here, in case there's something that happens that goes wrong, is log the error, just in case that there's something error in there, and so you don't get crazy. This is initializing the application. This is creating HTML5 canvas elements to display filters, evolution filters. This is loaded the TensorFlow.js model, which was converted from Keras model.h5, capture current frame, capture webcam's current frame. So this I'm adding because I'm just gonna push this when we finish. Predict filters with current webcam frame. All right, we need just to display those filters from the prediction, and actually to maybe what we can do is just refactor this a bit to be a bit more persistent. So get prediction. Right now we just do that, so we just return the prediction. So here we'll get the prediction as well. That's probably because it's not used, right? Yep. And now we use we're just gonna do something that is gonna be display filters. We just pass the prediction, so that function doesn't exist yet. We're gonna create it here. Function display filters, and we'll take a prediction. Oops. So the prediction input is gonna be norm 64. All right. So right now, this is the last part that we need to do, and yeah, I'm just gonna drink some water. I would get a sense of, is there anyone there watching? I would like to know who you are, if you are, or to hear how this is going. Right. I just realized that the webcam, when we started probably, I don't really know, but probably when we started using the webcam feed on the browser, the webcam reset, and I was appearing like this, right, with these two voids there instead of this. All right, so let's keep going. We don't have too much more to cover, and also, yeah, and Jose Luis will be live streaming in 40 minutes in his channel. So, okay, where were we? We need to display the filters. So we have the information. So we have all the information that we need, and you know, and that's just for visualizing the the canvases, right? So the same way that we did here. So again, we have 64 filters, so that's 8 by 8. So I'm just gonna use the square here to make it global for the application. So the square is gonna be there, and then we're gonna remove this one. So create canvases and display filters have really similar code, and the only thing what we need to do is to process the input, so the prediction, get one filter at a time, and set the filter as pixels on the canvas, right? So process the prediction. So we get one filter with TF squeeze, TF split, the prediction, 64, 3, the index, and then 0. So what this is doing, so TF squeeze is removing the first dimension. So we're removing this one. So right now here we have a this is 64. So we had this here, and we get, let's say, and we're gonna get here this, right? Whatever index we have. What we want to do now is, well, so there is an error that other times when I've tried this, right? What we need to do really is get the canvas. So document get element by ID at output index, right? So that's the canvas that we want to put the information in, and then we have this really handy function that comes from TensorFlow, where we could put our filter into that canvas directly, so that the information in the filter into the canvas. But there's one problem there that you're gonna see, and I'm just gonna let it crash so we see it. Well, there's an error. Okay, so async, and we're not displaying. Yeah, so wait. All right, so that builds. Still gonna see crash. So we get the webcam feed. I'm here, and predict is not defined. Get prediction. We changed the name. Right, that's not what I wanted to see crash. Okay, let's see now. All right. Tensor values for float 32 tensor must be in the range of 0 to 1, but got range minus something to minus something. So the frame that, the filter that we were trying to display here had the range minus something to minus something. But we need an image mapped to the D type, right? To what we saw initially, an image that has information that is a float 32 from 0 to 1, right? Representing the range of colors, instead of from 0 to 255, from 0 to 1. So that's what this is not liking, right? We need to input a vector, so a tensor like that, and this has a range ranging so from -1 to 1. So what we're gonna do now, we need a function that takes our numbers from the same but from 0 to 1, right? So what's that function here? So the filter mapped is going to be, so we first need to multiply the filter by 0.5, right? So that will take it from minus 0.5 to plus 0.5. But then we need to add 0.5. So that takes it from 0 to 1. And if we use this filter mapped here, hopefully we won't get any errors. Oh, nice. All right, so every time I refresh now, I'm gonna get my filter there. So let's get something that gives us more edges. So let's try this. All right, yes, and then the last part that I wanted to do, right, we can get, so the first thing we can do now that this is working, we can now go to our input and we can change it for 8. So I visualize 8 by 8, an 8 by 8 matrix, right? Let's try it. This might make my machine go a bit slow. It indeed did. All right, yeah, so there is a way we could have this happen live every time, but because right now I'm streaming, it doesn't really make a lot of sense to do it in a way that it's gonna happen live. One thing I wanted to try is, I think every time that I update this tab, my webcam gets the configuration of the webcam gets reset. Let's get something that has some more contrast to it, just to visualize a different thing. So let's just get this thing here. Yeah, actually, so the webcam actually resets the configuration every time I refresh this tab. Not the best. Right. So yeah, it seems like computers having a bit of a hard time to go through all of this, but we managed to go through the whole thing. So I think if we come back to here, what I was intending to show you, let's make a quick recap before I go. How to visualize convolutions with TensorFlow, right? We've created the simplest network or model in TensorFlow that I could think of to show how convolutional layers work. We use Google Coda for that. We've exported the model and we did visualize it with Neutron. So this is what we visualize. We learned how to customize the name of the layer so we can reference them by name as well. We converted the model using the TensorFlow JS format with TensorFlow IDs Converter. And we fed the model with the live webcam feed in TensorFlow.js, right? We've built a simple web app, used ES 2015 and compiled with JavaScript Laravel mix that we also had a live process there watching, so it would refresh all the time. And we've served the site so we could see those predictions. In this example, I had it running live, but I didn't really want to do it running live today because it seems like yeah, the machine slows down a lot. You're like making a lot of operations there, and I'm using Mac, so there's no GPU support. I would suspect that these are some of the tasks that Windows with an NVIDIA GPU would really excel at. And yeah, so we got started. So we saw the whole way of doing that. So we've gone like an hour and 45 minutes so far. The only thing that I didn't really go through that I wanted to see today, because I have never tried that, is this one. So let's see if I can do that. So I did use this. So I did use this command, TensorFlow JS converter. We said a model type keras. So where am I? Model JSON. So no. Actually, model.h5. That's on the desktop. H5 to output, let's say. Input format. Okay, my bad. Oh, input format. All right. Hopefully that works. That should go into output. Yeah. Okay, so that worked. The only thing I wanted to try is that directly from Colab, there is also an API. I just wanted to try it with you here today. So we're gonna open one of these Colab notebooks. So disconnect it. You see, this is what happens if you go out of Colab for a bit. It will disconnect from the runtime, and you would lose the files and the state of the machine that you were using before. All right, so we make a new notebook. All right, so we use this one. Let's actually not make a new notebook. So let's actually just make use the same notebook that we had before. And so we have this model running, so run all. And then here, I'm just gonna add some text. Export to TensorFlow JS. We need some code, so we delete this one. Yeah, and probably I should add some more sections here to clean this up a bit. Yeah, so AG. Maybe we should download this image from somewhere so we have something that so what we can do, maybe can we use curl? So let me just check one thing. right, let's just try with this image. So just gonna try by downloading this. Yes. Right, this seems like a better approach. So we first download the image. Yeah. Right, so now if we run it all, this should work all the time as long as this image exists. All right, cool. So if I do now here, I don't think this is gonna work, right? We don't have it here. So the first thing we're gonna do is pip install quiet TensorFlow JS and try to load it. So that's going to install TensorFlow JS and just load the library as TF.js. This is the same package that we had that I have here in my console. I just noticed that my audio volume wasn't high enough. Many things to learn. So TF.js, converters, and I'm just looking at here. Save Keras model, TF.js model. All right. Let's see. Well, that would be really handy. If we don't have to use the converter locally, we can just save directly. Oh, that's there. All right. So it seems, let's just try to zip that. Google Colab download file. There's a way that you can download with Colab, so it automatically, you see, from colab.colab, so from Google.colab import files. So these would be import Google, or from, right? From Google.colab import files. Files download TF.js model. Okay, so let's see. So we can put here parameter. So TF.js model name. We can put here ShuffleYes model, and we're just going to use that variable here. That, and I think we can use this here. All right, so this should install TensorFlow JS. It should create the model and zip it, and then it should download it. So we got it here, download it, and oh, it's empty. So what did happen there? Oh, okay, we need to see recursively. So let's try again. Yeah. Okay, so we have the model here, and I wouldn't expect it to be any different than the other one. So yeah, that would be something we can directly use with our with the code that we've done All right. Well, so that was the live stream. So I'm pretty happy I got through all of the things that I wanted to cover today. It took us 2 hours, a lot longer than I thought it would, but I guess this is always like this. And yeah, I would invite you, if you like this, maybe just type some comments and let me know what you think, what parts you liked, what parts you didn't like that much. And also, if you want to see more of this, let me know. And also subscribe. So there's, I think it's right there. So there's a link or like a small thumbnail where you can subscribe to the channel. It's important also, you need to set the notifications, otherwise you won't get notified of new live streams or any new videos that I do. And also I'm on Twitter, so you can follow me at Nono.ESP, NONOESP. And yeah, thanks so much for watching, and I hope you enjoyed it. I'll see you next time.